I slept on myself for way too long. I underestimated the gifts that God gave me for way too long.
Hello entry students, welcome to entry lessons science table, and today we're going to be learning about direct current motor status. Okay guys, talking about motor status, you need to know this. The EMF starts at 0, which means in order for this EMF to work, we need a higher starting current. We need a higher starting current for this EMF to rise. And what do we know about higher starting current? We know that the higher starting current is very dangerous. It is very dangerous, right? So for us to limit that danger or to avoid that danger, we have to add resistors and resistors, right? The more we add the resistor, we limit the higher starting current, right? But guys, those resistors that we, the resistance, let me just say the resistance, we add the resistors, right? Those resistors that we are adding, it cannot be permanently connected in the armature circuit. It cannot be connected permanently, cannot be connected permanently, right? Know that it cannot be connected permanently. Why? Because it will cause the motor to become slow, right? It's going to cause the motor to become slow or sluggish. It's going to cause the motor to become slow or sluggish, and it will not reach its full load, right? It won't reach its full load. Okay guys, summary of what I've just said, right? So the EMF of a motor starts at 0, and for it to grow we have to have a higher starting current, which is very dangerous. So to limit the highest starting current, we have to add the resistance, right? The resistance. But for the machine to work, the resistance cannot be connected permanently, because it will cause the motor to become very slow, sluggish, and it won't reach its full load or full speed. Okay, moving on guys. So we talked about the resistance, right? We said that the resistance cannot be connected permanently, right? Because it's gonna cause the machine to be sluggish and it will not reach its full load speed, right? So the resistance must be added, right, in order to limit the current, right? But as we add the resistance, we only add it for the purpose of starting, right? We only add it for the purpose of starting the machine, right? For the purpose of starting the machine. So when the EMF increase, when the EMF gradually increase, we have to remove each resistance, right? The moment that the EMF start to increase, we have to remove each resistance until the EMF reach its full value or maximum value, right? And to achieve this whole thing, we have to be using the what? The face plate starters, right? We have to be using the face plate starters. So in order for us to work out everything here, from the resistance to the EMF and the higher current, we have to be using what? The face plate starters, right? Which includes protective devices. It includes of protective devices, right, against short circuit, and protective devices against short circuit and overload. Know that. So the summary of what I've just talked about, guys, we only add the resistance for the purpose of starting the motor, right? And when the EMF gradually increase, we remove each resistance until it reach its full value, right? So the faceplate starters, for the whole thing to work, we need to be using the faceplate starters, which consist of protective devices against the short circuit and against overload. Let's move on. Okay, so how to draw the faceplate starter, right? We have two faceplate starters. It's either we have series, or it's either it's in series or it's in parallel, or they can say shunt. It's either it's shunt wound or parallel, or it's in series, right? That's what they use this. Sorry about that. Right, so the faceplate starter, it's either it's in series or parallel. If you don't want to say parallel, you can just say shunt, right? So I'm starting with the series faceplate starter, right? So here we get it from the supply. Let me just start it here. Here we get it from the supply, positive supply and negative supply, right? And it's going to move further, and then we're going to have a protective devices. As they said, it consists of protective devices. We have O, L, R here, right? And it moves, it makes something like this, right? And then it's going to have a arm. We call this a spring-loaded arm, right? And coming on the negative side, we're going to have a limiting resistor, right? To have this, and something U-shaped. You guys must be able to draw the faceplate starter, both series and both parallel, right? and this is going to have something like this. I don't know how to draw, guys, but hopefully you guys can draw. I know you guys did this, like, you guys did this on N2, right? Yes, on N2 we also did the faceplate status, and we're gonna have something like this. Right? Drawing this is quite difficult, yeah? Yeah, it's quite difficult. Maybe it's because I don't know how to draw, ne? But if I knew, hey, you guys must fear me. Goes over. Three and yo, guys, man, yep, it's quite difficult, but as long as you guys practice, right? But as long as you guys know about the basics, because what makes me understand this, guys, to me is the basics, right? The more you understand the basics, the more you understand the whole process. Okay, this is a series face plate. Why? Because armature and coil is connected in series. Okay, guys, for this to work, the operation of this to work, know that the current is drawn, right, from the motor. It is drawn by the motor that passes through there. The current is drawn from here, and then it will pass through the overload relay, allowing the coil to produce magnetic field. But this magnetic field is too weak to attract the armature, the iron armature, right? Immediately, this, we call it the spring-loaded arm, right? Again, the current moves, is drawn from the supply, and then it will enter the overload relay. And this overload relay causes the coil to produce magnetic field, but that magnetic field is too weak to attract the iron armature, right? And immediately after this, the current is drawn, the preloaded arm is moved to position 1. Here is position 1. It's going to move here, right? It's going to move here. And when the EMF, like we talked about it, guys, we said when the EMF gradually increase, know that it will move from this arm to this one, number 2, right? So this resistor will be eliminated, it will be removed. So resistor number 1, let me just draw this. These are the resistors, guys. This is resistor number 1, this is resistor number 2, and this is resistor number 3, and these are the arms from the spring, for the spring loaded arm. So the spring loaded arm will first reach here, and the EMF will gradually grow. And when the EMF increased from this side, it will eliminate R1 and it will go to 2. And when the EMF increases, it will eliminate R2. It will go to R3. You see, R3. And when the EMF increase, it will eliminate R3 until it reaches to NVR. And then when it reaches this NVR, it will work normally. It won't need resistance anymore. That's why we said we only need resistance to start the motor. And know that this system is self-regulated system. It works by its own. It doesn't need help, right? This system is self-regulated, right? It doesn't need anyone's help, right? So that the more the arm moves from arm 1 to arm 2 to arm 3, the resistance is reduced or eliminated. It is eliminated one by one until it reaches the NVR, and when it reaches that NVR, it will work without any help. It will continue to work. I'm so sorry, guys. I don't know how to draw this perfectly. I'm not good with drawing, but here is the picture of the parallel faceplate. You see here the coil, the action is connected in parallel to the armature, right? And this is the one that I just drew. No, you notice that the armature is connected in series with the coil, you see. So this is how you see. So this spring loaded arm will reach arm 1 and EMF will increase, and when the EMF increase, R1 is eliminated, goes to R2, and the EMF will increase, and then R2 is eliminated. R3, when 3 the arm 3, the EMF is when the EMF increases, R3 will be eliminated until it reaches NVR, and from NVR it won't need any starter. It will just continue to work without any help from the resistance, guys. And know that, guys, overload relay, this is overload relay, right? When the current is higher, you see, when there is overload current, this thing will trip the whole system, and the arm won't be able to eliminate all the resistor for the starting. And if it doesn't reach the NVR, the system is not gonna work, so it will degenerate the whole system. It's not gonna work. And okay, guys, here is no overload relay, right? I mean no volt relay, yeah, something like that. It is no volt relay, yeah, no volt relay, right? The function of this, it is to automatically close the circuit if the current, if the voltage, no volt relay, know that no volt relay works with voltage, right? So it will automatically close the circuit if the volt is below the rated value. If the voltage is below the voltage the is below the volt value, it will stop automatically close the whole process. And here it's overload relay. This one works with the current. This one works with the voltage. If the voltage is below the rated value, it automatically closes. And this one also automatically shuts the whole process if there is short circuit or overload. This one works with current, this one works with voltage. I'm teaching straight from the textbook, right? Okay guys, so we have two types of protective devices. We have electromagnetic and thermal type, right? So this one is electromagnetic, OLR. Remember that I've said OLR works with the current, right? So know how to draw this and please know how to label it. Eh? This is the coil, this is the armature, this is the oil, this is the piston, and this one is the rotating disc, right? So how does it work, the operation, right? So a large fault current converts the coil into a strong electromagnet, right? So the electromagnet then draws the end armature upwards. This movement is slowed by the piston attached to the iron armature, which must displace the oil in a tank or a slump. When the iron armature has moved a sufficient distance upwards, the tripping mechanism is activated. The rate at which oil is displaced determines the time taken by the iron armature to activate the tripping mechanism. So the relay is said to have inverse time current, which means the larger the fault current, the shorter the tripping time. So meaning guys, when there is a large current, the coil are turned into a strong electromagnet, which is going to attract what? The iron armature. But the process is slowed down by what? By the piston connected here at below the armature current, right? And when so guys, when the armature has moved a certain distance upwards, the dripping mechanism is activated. So this has to move up. It has to move up, and the time it takes for it to drip, it is determined by the oil. So this oil determined it, and they said that we read that it moves in an inverse time, which means the larger the current, the uh the shorter the dripping time, right? So the larger the current, the shorter the dripping time. Now we move on here to here, and this one is the thermal OLR. Also works with current, right? So the operation, the thermal type overload relay has a bimetal strip inserted above a heating element. This is a heating element, and here we have a bimetal strip. I know that bimetal strip is made up with two metals, right? The bimetal strips is made up of materials which have different coefficient of expansion. Yes, the other one can expand while the other one doesn't. A heating element is connected in series with the overload. Yes, we have a load which is connected in series with a heating element, right? And during an overcurrent, it will cause the heating element to hit the bimetal strip. When there is overcurrent, the heating element will hit, which will overheat the bimetal strip. And because of that coefficient of expansion, guys, right, between two metals, again, the two metals will expand when heated, but not at the same rate, causing the strip to bend to activate the rip mechanism. So bimetal strip will bend, causing the whole mechanism to rip. So know how to draw that, guys. Know that, how to draw that, how to label it, and also do the operation, right? And that is all with the faceplate. And thank you guys for tuning in my YouTube channel. Thank you for the love, and please subscribe, please share and tell other people about the channel, and let's continue to grow and learn together. Thank you. Bye.